You drop an object with no air resistance. It accelerates downward 9.8 meters per second squared. If instead you throw it down, what's its downward acceleration after you release it? What's the verdict? 9.8. Because the acceleration is determined by the force acting on the object. We'll learn that in a couple of weeks. And the only force, once you release this thing, the only force acting on it is gravity. So it's the acceleration of gravity. Okay, free fall. Still in your hand, it could be higher than that? Yes, yes. Yeah, because then you have your hand pushing on it and gravity both. Question? So if there's air resistance, that changes things. Yeah, if there's air resistance, then the acceleration due to gravity is going to, then the acceleration of the object is going to be what? More than 9.8, 9.8, or less than 9.8? Less. If it's on its way down. What about if it's on its way up? The only force acting on it is that of gravity. You got the force of gravity down, but you've got the air pushing up on it, right? Okay, those are vectors. So the air pushing up subtracts from the force of gravity, and you get a smaller acceleration than 9.8. And the force of the air, it turns out, it's a little complicated. It's proportional to how fast the object's moving, right? Because the object is pushing the air molecules out of the way as it's dropping. And so as it goes faster and faster, it hits more and more air molecules in the same amount of time, right? So that force increases with speed. So as the object falls faster and faster, that arrow gets bigger and bigger, the force from the air pushing up, the air resistance. But the force of gravity is the same, right? And so eventually those two arrows equal one another, and that's when the acceleration goes to zero and the velocity doesn't change anymore. We call that terminal velocity or terminal speed. So with air resistance, things eventually top out when you drop them. They eventually hit some terminal speed and they don't go any faster. But when you ignore air resistance, or if you could drop something on the surface of the moon or in a vacuum, then the speed constantly increases, right? Because there's a constant acceleration. The speed is always increasing. It just keeps going faster and faster and faster. We're just looking for the magnitude of the acceleration. Everything was defined as going downward. The ball was going down. We know the force of gravity is down. So all we were looking at was the magnitude of the acceleration. But sometimes we use, but you can define any direction you want typically, and just make sure as positive. So if you pick up as positive, you know the force of gravity is down, so the acceleration is negative in that case. If you define down as positive, then the acceleration of gravity is positive in that case. So just remember which direction the force is and how you define the positive direction. Okay, how about this one? Car moving along a straight track. That's position as a function of time. What's happening to this car? The rate is slowing.
Yes.
Yeah, okay. Anybody else? Yeah? Yeah.
I think it's slowing down the entire time because the amount of distance traveled versus time shows that it's going less and less. And so technically the slope is the highest at the y-axis, and then after that you slow it down because the slope decreases.
Looks like this, right?
Yeah.
Okay. Slope is one way. Another way to think of it is in this time interval, right, from this time interval from 0 to whatever, 1 line here, it's gone a big distance, right? And in this time interval, same time interval, it's gone a much smaller distance, right? And in this time interval, I'll do it out here. In this time interval, it's got an even smaller distance, right? So as time goes on, it covers less and less distance in the same time interval, right? That's one way of looking at it. Another way of looking at it is the slope at any given point. So the slope at this point is a big positive number. The slope at this point is a much smaller positive number, right? As time goes on, the slope gets less and less. So, and the slope is the instantaneous speed, right? That's another way of looking at the time interval. We good? Okay. So this is slowing all the time. We good now? Good question. The question is, does the starting point matter? If it starts at x equals 0 instead of at x equals 10, does that make any difference? No. So it's because it's sort of arbitrary where you pick x equals 0, right? You might pick one location on the road to be x equals 0. I might pick a different location on the road. But the motion of the car, we both should sort of get the same thing. We both should see it as always speeding up or always slowing down or same changes in speed. Okay? Yeah. The slope at any given point, starting at t equals 0 and moving to the right, always gets smaller and smaller, the slope at any given point on that curve. And the slope is the instantaneous speed at that point. Okay? So the slope is getting less and less. And what is the slope? It's a change in position over the change in time, which is the velocity. So the velocity is getting less and less as time goes on. The slope would have to be increasing. How would I? It would have to have this kind of a shape for it to change. See that? So at this point here, this time interval, it's speeding up. And for this time interval, it's slowing down. Does that help? The slope, the whole time up to the dashed line there, the slope is increasing at any given time, right? The slope gets bigger and bigger. And then once you cross over the dashed line, the slope is always getting smaller and smaller. And the slope is the instantaneous speed. Does that help? This one. You throw a ball straight up in the air. At the highest point, what happens to the velocity and the acceleration?
Oh, we just did this one. You said it was not 0. That's true.
What's the acceleration? I'll do it this way. Right? It's very tempting to say the acceleration is 0 there. But think about this. What does acceleration tell us? It tells us how the velocity changes. So if we know the velocity is 0 when it gets to the highest point, and if the acceleration were also 0, what would happen to it? It would stay there. So if the velocity is 0 at one instant, and it's not 0 at the next instant, then there had to be acceleration, right?
Yeah.
Okay.